Going to continue with our lessons, and I am still writing with my finger. Hopefully this will be the last lesson. We are going to begin 3.6, solving multi-step inequalities. We have already, in this chapter, dealt with multi-step equations, which means an equal sign is involved. And now that we are studying inequalities, we will move on to the multi-step. So our question is, find the average number of goals your team needs to score. So this is what we're looking for, the needs to score per game to break the school record. Let G, that's going to be our variable, represent the average number of goals scored per game. So let's look at the information they give us. Your school soccer team is trying to break the school record for goals scored in one season. So it's said in the question. Your team has already scored 88 goals this season. Whoa, sorry about that. Let's see if I can just fix that without going, my goodness. All right, let's just do 88 goals per season. This record is, the record is 138 goals. With 10 games remaining on the schedule, how many goals on average does your school need to score per game to break the record? The first thing I'm going to do is, some of you might be in fear because you see the word average and you don't remember that formula, but I'm going to go ahead and get rid of that word here because they give us information about everything they're giving us is in average numbers. So I'm just deleting. That one didn't look like much of a delete symbol, so it doesn't scare you too much. So I'm going to have to look at how I'm going to construct my inequality. I am going to have a constant term. I am going to have a variable. So a constant term is something we already know that cannot be changed. We have two constant terms in our information here. We have that our team has already scored 88 goals. And this is what the information we're working with. And we know that the record that we're trying to get to is 138. Those are our constant terms. Those will not change. Now, it says that we want to beat the record, and since the record is 138, we want our goals on the left-hand side here to be larger. So I'm going to say they have to be greater than. So 88 goals is what we have already, and we need to figure out how many G, our variable, how many goals we need per game. So 88 plus the remaining games, there's 10 of them, and in each of those 10 games, we need to earn goals. So that's going to be my variable. So if I take the 88 we already made, plus 10 games with possibilities of goals in each one of them, that would be our variable, because we would multiply that by how many games we played. That is how we would go ahead and write a multi-step inequality. The next steps would follow the same procedure we did with equations. Move your constant terms so that they would be on the same side of the inequality. So we need to subtract 88 from both sides. And when we do so, we're going to make an equal sign because we are computing going down all the way across. 138 minus 88 would give us 50. Keep your inequality the same. We did not do any multiplying or dividing by negative. And on the left side, we still have our coefficient and our variable. Now to solve for a single term or a single variable, we need to divide by 10. Divide by 10 on this side as well. And again, it was a positive, 10 over 10 equals 1. So I have 1G. We divide by a positive, so the inequality symbol, although sloppy, remains the same. And 50 divided by 10 is 5. So we need to score more than 5 goals per game to break the record, an average of that. The reason they're using average is if on one game we score 7, we might not need to do 5 on the next game, we'd be okay still with 3 goals. But the main idea of this example was to solve or to write an inequality. One more multi-step inequality for us to just remind ourselves of the rules. So here's our inequality. Here's our variable, and the coefficient is still there. It's just a divided by. We're going to do what we have been practicing. I'm going to change colors here so you can see what I'm doing. I'm going to get my like terms together. So I'm going to do the opposite of negative 6 is positive 6. Do it to both sides of the inequality symbol. Going to make a large equal sign because we're computing going down. Negative 6 and positive 6 cancel each other out. We are left with our variable, or our variable expression, because x is being divided by 4. No multiplication and dividing has happened yet, so my symbol stays the same. Whoops, I'm sorry. And a negative 5 combined with a positive 6 would leave us with 1. Now I need to get my variable isolated or by itself. So instead of dividing it by 4, I am going to multiply it with a negative 4. I changed colors so you can see this is my next step. And if I do that on one side of the inequality symbol, I need to do it on the other. Negative 4 on both sides. A negative 4 over negative 4 gives me a positive 1. So that gives me my x variable by itself. I was multiplying by a negative, so I need to reverse the symbol, and 1 times a negative 4 would give me negative 4. As simple as that. Same as equations, except for our one rule of if you multiply or divide by a negative, you need to make sure that you reverse the inequality symbol. So our last one is combining like terms in a multi-step inequality. Again, we had the same concept in equations. So first we'll write it. You plan to go ice skating often this winter. The skating rink charges $4 for admission. You can either rent ice skates at the skating rink for $5 per day or buy your own pair for $45. How many times do you have to use the ice skates in order for the cost of buying them to be less than the total cost of renting them? Again, I am going to look for my constant terms. One constant term is $45. I'm going to go ahead and put $45 into my equation. Now this equation is going to be the equation which is going to tell me for option 2, renting. Buying. This one is buying my skates. So I'd have to have skates to go ice skating, so $45. What else do I need to have to go ice skating? I need to pay the $4 admission. Now I don't know how many days I'm going to go, so I'm going to go ahead and I'm going to let my variable be a D for days. So $45 plus $4 per day would be the equation for how much I would have to pay when I go skating this winter if I own my skates. Now, if I rent my skates, I would instead need to pay the rental fee, which is, I'm going to change colors here again so you can see the difference. The rental fee would be $5 a day plus the admission fee, which is $4 a day. Again, my variable is D for days because I don't know how many days. That's what it's asking me. How many times must I go? Now, if I want to know when it would be better for me to buy my skates, I want this equation to be less than the rental equation. Now I need to go ahead and simplify my terms first. Notice I have two variables on this side. I need to simplify those first. Some of you were missing this step earlier in equations. So simplify first. And now I can start to go about combining like terms. Now I have a constant and a variable and a variable. So let's get our constants together. I'm sorry, our variables together. And now it's with me. Variables together. Again, doing some computing. What remains on the left side is my constant term. 40 minus 40 leaves nothing. My inequality symbol is still less than, and 9d minus 40 equals 5d. Now I need to solve for my variable. So I want to divide by 5 because 5 over 5 equals 1, giving me my 1d. No negative involved, so I can leave my inequality symbol the same. And I will go ahead and divide the left side by 5 as well. 45 divided by 5 would give me 9. So the amount of days need to be greater than 9 days in order for buying or purchasing my ice skates to be a better deal. Now again, if you were going to graph, remember you're always going to put your variable first. I'm just reviewing this because I think some of you missed this last lesson. The inequality symbol is not pointing at the variable, it's pointing at the constant term, so I need to keep that the same. I'm actually changing the whole equations order that I'm going to read it. And this concludes examples for lesson 3.6.